Homework problem 6A. What volume of carbon dioxide gas forms when 1 liter of oxygen reacts with 350 centimeters cubed of methane? Assume the temperature and pressure remain constant. Water is also a product, or the other product. Alright, sounds like a stoichiometry problem. Let's write down the information that we know. So it wants to know, here's the question, what volume of carbon dioxide will form here? Okay, so what volume of carbon dioxide, so I'm going to put carbon dioxide and question mark volume, okay? Forms when 1 liter of oxygen, so 1 liter of oxygen reacts with 350 centimeters cubed of methane, so it reacts with methane, so CH4, but it's 350 centimeters cubed. That's always a fun unit. And it says that water is also produced. Okay, so we know that we have a stoichiometry problem. Why? Because we have a lot of things in this problem. We have oxygen, methane, forming carbon dioxide, and water. We also know we have a limiting reactant problem because we have amounts for each reactant. So that means that we need to do a limiting reactant step beforehand, before we can answer the question and find out what the volume is for the carbon dioxide. So since this is a stoichiometry problem, step 1, write a balanced equation. So is this balanced? I see 4 hydrogen here, but only 2 over here, so let's start with that. And 2 is an even number, so that's a good thing. I've got, let's see now, I've got 4, I've got 1 carbon, so it looks like I just need a 2 there. And I believe I'm balanced on both sides, and I am. Alright, so I need to do what's called a limiting reactant step. I need to find out which reactant will be totally consumed first. Or if you want to find out which will be in excess or have extra, that's also okay. So it doesn't matter, pick one. And I'll just start with the oxygen, since it's first. Doesn't matter, you don't always have to, you can always start with the methane you want. But what I'm going to do is I'm going to, since it says that the temperature and pressure remain constant, I'm going to consider the situation at STP. So to speed things up, and if you need to do PV equals nRT, that's fine. I'll give you plenty of time on the test to do so. But for the sake of speed, I'm going to use the conversion. So I'll start with the 1 liter. 1 liter of oxygen. And, so 1 liter of oxygen. And I'm going to convert that into moles because, again, we still go through the same steps for stoichiometry. So, 1 mole of oxygen has a volume of 22.4 liters. Okay. So that's step, So that's step 2. Step 3, I want to get rid of moles of oxygen and compare it to my other reactant, which is methane, so CH4. And I'll put in my values. I have a 2 and a 1. So 1 here and a 2 there. Okay. And I also want to change back into the desired unit. In this case, it's in centimeters cubed. So what that means is I need to convert the moles into liters, and then I'll convert the liters into centimeters cubed. So I'm going to have my 1 mole of methane, which is equal to 22.4 liters. And remember on the quiz when I gave you the conversion that 1 milliliter equals 1 centimeter cubed? That's what we're going for. So I want to change my liters into milliliters. And then just, let's move it over. So there's 1,000 milliliters in every liter. Now here's the biggie. For every 1 milliliter, that equals 1 centimeter cubed. Okay, so a little bit longer of a process. And I'll go ahead and identify that this is step 2, that's step 3, and all of this is step 4. So I'm converting to the desired unit, which in this case is in centimeters cubed. Now, we could cancel a couple things out. We don't really need to focus on the 22.4s. So if I do 1 times 1 times 1 times 1,000, so I've got 1,000 on top, divided by 2, that gives me 500. So this equals 500 centimeters cubed. Okay. So here's how we talk ourselves through this. If I used all 1 liter, and this is of methane, okay, if I used all of my oxygen, the 1 liter, I would need at least 500 centimeters cubed of methane. I only have 350. So my limiting reactant is my methane. I am not going to be able to use, I repeat, I will not be able to use all of my oxygen because I don't have enough methane to completely react with it. I only have 350 centimeters cubed. So knowing that that's my limiting reactant, that's the number I'm going to focus on to answer the question, which is what volume of carbon dioxide. So I will start with my 350 centimeters cubed. Actually, let's move that on down. 350 centimeters cubed of methane. Actually, let's scoot it on over. So I'm going to convert the centimeters cubed back into milliliters, and those are 1 and 1. Okay. Then I'm going to convert my milliliters to liters, and that is 1 in 1,000. Okay, so now that gets me ready for my conversion, which will now be 22.4 liters equals 1 mole. Of this case, it's of methane. Okay, so all of this is step 2. Okay, step 1, write a balanced equation, which we did up here, so we're good. Step 2, convert what was given into moles. Now again, what you would need to do if you were doing PV equals nRT, you would need, let's get a color here, you would need to do this separately before you plug it into PV equals nRT. So you can get your liters and then you can plug it in. Okay? So let's get rid of that yellow. A little farther. Okay? So now I'm ready to do my mole ratio. So moles of methane to moles of carbon dioxide. And what were the values there? So it looks like 1 and 1. So that's really fun. And then the question wanted to know what the volume is. So again, 1 mole of any gas is 22.4 liters. So is there anything I can quick math here? Doesn't look like, oh yeah, here we go. We can get rid of the 22.4s. So 350 divided by 1,000 is 0.35. Isn't that fun? So 3.5, and that is liters of our carbon dioxide. Okay. And let me shrink that so you can see it all. Okay, so again, if you needed to, blow that up just a little bit more. Okay. So again, be sure that if you have amounts for each reactant, you must do a limiting reactant step to find out which one of these is going to be totally consumed first. And then once you know who your limiting reactant is, take that amount, not this amount, take that amount and answer the question. Okay? All right, let's look at the next one. Okay. So 6C. Question says we have 30 liters of nitrogen gas that reacts with 75 liters. So we've got 30 liters and we've got 75. So that means we've got ourselves a little limiting reactant situation here. Question of hydrogen gas to form what volume? So here's our question. To form what volume of ammonia gas, assuming that the temperature and the pressure remain the same. So here we go. So we have 30 nitrogen, so 30 liters, and we're going to react that with 75 liters of hydrogen. And it's going to form ammonia. And the question wants to know what volume. Okay. So again, once you have all that, you really don't even need to see the rest. So let's balance this out. Step one, write a balanced equation. So it looks like I got 3 hydrogen, 2, so I need a 3 here, and a 2 there, and 2 nitrogen. Looks like I'm balanced. Okay? Doesn't matter, pick one. So I'm going to go ahead and just pick the first one. So, and again, we are assuming the temperature and pressure remain the same, so it's safe to say we're at STP just to make life easy on ourselves. So I'll start with the 30 liters of nitrogen and convert that into moles. So 1 mole of nitrogen has a volume of 22.4 liters at STP. Okay, so step 1, write a balanced equation. Step 2, change it to moles. Then we're going to use our mole ratio. So 1 mole of nitrogen, mole of nitrogen to moles of hydrogen. And then we get our numbers. So hydrogen has a 3, nitrogen has a 1. Then let's go back to our desired unit, which in this case is liters. So 22.4 liters. And let's get a value there. So it looks like we can cancel mental math. So 30 times 3 is 90 liters of hydrogen. Okay. All right, so here we have to talk ourselves through this. If we used all 30 liters of nitrogen, I would need at least 90 liters of hydrogen. How much do I have? Not enough. Very good. So that is my limiting reactant. There is no way that I'm going to be able to use all of my nitrogen because I don't have enough hydrogen. I need 3 times as much of hydrogen as I do my hydrogen. Okay. So my hydrogen is my limiting reactant, so I'm going to use that amount to answer the question, which is asking for the volume. So 75 liters of hydrogen, right? Yeah, hydrogen. Okay, so again, 22.4 liters for every mole of hydrogen. Use the mole ratio. Let's get rid of the moles of hydrogen and go to moles of nitrogen, ammonia this time. And so I believe it's a 2 and a 3. Yep. And then we're looking for the volume, so last step. 1 mole is 22.4 liters. So we can cancel 22.4 liters. So 75 times 2 is 150, divided by 3. 50 liters of ammonia. These are actually pretty fun. Okay, so take a look at that. Whole problem there.